So today we're going to do the third part of structural design for precast parking structures, and we're going to talk about connections, about horizontal components and considerations, and about vertical components of precast prestressed concrete. The objectives are to provide an understanding of the considerations of connection design for prestressed and precast concrete parking structures. We're going to look at load paths, anchorage to concrete, loading conditions, and the types of connections that we use. Then we will try to provide an understanding of considerations for horizontal components for precast prestressed concrete parking structures. We'll look at double T's, inverted T-beams, spandrel beams, and flat slabs and stairs. Finally, the third part, we will talk about the considerations for vertical components for precast prestressed concrete parking structures. We'll think about interior columns, exterior columns, ramp walls, shear walls, and stair walls. So we'll start off with connections, and this section may run a little bit longer. The other sections are shorter, but there's a lot of material here, and when you get a set of erection drawings from a specialty engineer or a precast concrete manufacturer, you are bombarded with an enormous number of details that are very specific. At the level of erection drawings, we are down to the specific information for every part, every nut, every bolt, and every weld that needs to go into connections that are applied at specific locations. And it can be a little bit intimidating when you have to do a review of this. But there are things that are basic that we keep in mind that are the challenge of providing connections in precast concrete. ASCE 7 section 1.4.2, and it hasn't changed in ASCE 7.16. Right at the beginning, it's beginning to talk about the integrity of the structure. All parts of a structure between separation joints shall be interconnected to form a continuous path to the lateral force resisting system, and the connection shall be capable of transmitting the lateral forces induced by the parts being connected. Any smaller portion of the structure shall be tied to the remainder of the structure with elements having strength to resist the force not less than 5% of the portion's weight. This is a very, very broad requirement that has been subject to some confusion. It has been part of ASCE 7 for more than 20 years, and it actually required some kind of interpretation, because if I keep accumulating the parts of a structure through all the way to the vertical elements of the lateral force resisting system, I may be designing for forces and connections much higher than what the system actually requires. In order to clarify that, a clarification was obtained from the ASCE 7 committee decades ago that says, well, it's connected to the lateral force resisting system. The diaphragm is part of the lateral force resisting system. So this does apply. The diaphragm is designed on its own, but here we're getting the loads at least to connect everything back to the diaphragm to provide the lateral support. And it's key, it's part of the integrity and of maintaining load paths for our structure. Connections define the load paths in precast concrete structures. The behavior of the overall structural system is largely controlled by the connections. We have joints, we have connections. Forces don't cross open joints. They cross by routing themselves through the connections. And connection stiffness and deformation capacity is as important as strength in the consideration of the design of connections. Most precast concrete connection details are directional. That is, they're not monolithic joints. Usually, they are usually set up to specifically transfer a load in a specific direction or multiple directions, but not to create restraint in undesired ways. And one of the bedrock key portions of ACI 318 is to provide for anchorage to concrete so that we can develop our connections at these joint interfaces. Tension breakout is covered in the PCI design handbook. Breakout rules and calculations are aided there. Then anchorage to concrete also considers shear in connections that are pushing near edges or away from edges or in corners. All of these things are evaluated in order to determine that we have sufficient strength in order to meet those requirements. But not always can the configuration be developed that would prevent concrete breakout. And so this slide is labeled confinement reinforcement. It's probably also appropriate to call it anchorage reinforcement, because these are options on the left to provide anchorage reinforcement to develop tension to avoid the limitations of concrete breakout.